Hello and welcome to session number 13. Well, today we're supposed to do things outdoor. I was going to present to you how to do organic matter testing, but the weather is very, very wild. Well, there you go. Number 13. What more can I say? So we're going to postpone this a little bit, and today I'm going to leave soil analysis for a while and start talking about leaf analysis. Leaf analysis is very, very important because after all, what you eat, you eat the plant, either the leaf, if it's a leaf crop, or the fruit that comes from the leaves, because the leaves are actually the manufacturing part of the plant as a whole, or the bulb, or the grain, whatever, it's all made in the leaf. And you often hear people say that, for example, spinach is high in iron. Or you will find, let's stay on that. Spinach and iron. That's a classical Popeye kind of example. But this doesn't mean that other plants don't have iron. Every plant, every living thing will have to have all of those essential elements. All of them, without any exception. And that's what defines an essential element. Okay, because there are three criteria that establishes the essentiality of an element. Number one, any given plant must be unable to complete its life cycle in its absence. Why does it say any given plant? Because some plants have certain minerals being essential to them, but they're not essential to other plants. So any essential element that we list here will have to be essential to all plants, by definition. Secondly, it must be directly involved in plant metabolism, either structurally or functionally, or both. Well, that's number three, really. That's okay. In other words, its function must be either to help the plant live, to help it perform its functions, or it's a building block, or it can be both. And back to number two, its function must be irreplaceable by another element. So if one is low, we can't replace it by anything else. So if all of these three conditions are met, then this makes the essential element essential. Okay? And this is the list of what is referred to as essential elements. They are the elements that you will find in all plants. However, back to the story of Popeye and iron in spinach. Whilst you will find all of these elements in all plants, some will have them in higher concentration than others. This is very true. Now, if you want to have a good source of potassium from a plant source, what do you eat? You eat bananas, because bananas are very high in potassium. So this here, I'm not going to talk about them one by one. You will see a copy of this below, under the presentation. It gives you the range of all of these minerals as we expect to find them in plants. Now, we start here with nitrogen. We say that nitrogen can be expected to be at anything between 1 to 5% in plants. Some will have higher levels, some will have lower levels. Now, it's virtually impossible for anyone to know or memorize what are the levels that you should have of all of these minerals in all plants. However, if you look at the minimum levels here, and someone tells you, or you do an analysis and it tells you that the nitrogen level in your crop is 0.2%, you can rest assured that it is deficient. Anything under 1% nitrogen is deficient. But look at the range, 1 to 5. Look at potassium, 1 to 6. Now, of course, you can have it higher, you can have it lower, but this is the normal range of deficiency and sufficiency that you are going to expect to find in different plants. So it would be natural to say, of course, then, if we're looking at bananas, we would expect the potassium level, or rather the sufficient potassium level, to be in the high range. So whilst 1% potassium could be sufficient for one crop, for bananas, it's not, definitely. Now, this looks complex, and it is. And I don't expect anyone to memorize this. You'll have this for reference. But it's mentioned here because, as a gardener, when you grow a handful of crops, or maybe one, or maybe 10, I don't know, you will need to familiarize yourself with the deficiency symptoms of these minerals on those particular crops. At least familiarize yourself with that. So when you see those symptoms happen, you will say, it's such and such deficiency. Because if you have 500 square meters and you're growing a little veggie garden and there's a few trees here, you have a citrus tree, let's say, and a banana tree and an avocado. I'm giving an example here from Southeast Queensland. You're not going to have a leaf sample taken for each and every one. Let's be realistic. But if you're familiar with those symptoms on those crops and you see any one of them on your trees, you're going to say, voila, I've got such and such deficiency. Now, to complicate things, unfortunately, a little bit, if you're growing things on the same soil, you cannot expect them to exhibit the same levels of minerals. Just like we said, because bananas are high in potassium, they will absorb more potassium. Because spinach is high in iron, it will absorb more iron. So when you grow different crops on the same soil, you are going to get a wide range of difference between the levels of minerals on them, depending on two things actually. Their ability to take out these nutrients from the soil, and it's something that comes with their genetics. And secondly, with the existing level of minerals in the soil and their form. So some plants will be more efficient in taking certain things than others, while others are less efficient. Now I'm going to show you here a table that represents different levels of minerals of crops grown on the same soil. Now, again, I'm not going to bamboozle you with all of these figures, but I will have them listed again at the bottom of the presentation and you can look at them. Now, just look at one of them, nitrogen. On mangoes, it's 1.5, citrus 2.1, macadamias 1.6, avocado nearly 2.5. A big difference. There's a big difference between this figure and that figure. Look at the phosphorus levels here, 0.09, 0.16, that's nearly 70% higher on the same soil. So if you have a soil and you're growing citrus on it and you're satisfied with its level, with its performance, and then you expect that it's going to do well with mangoes, no, not necessarily. And remember we said that bananas require a lot of potassium. Okay, well, by the same token, citrus also requires a lot of calcium. Okay, and even though this level 2.48, nearly 2.5 here, it's about 50% higher than that on mango, it is still by definition very low. Look, on macadamias on that same soil, 0.5. So how do we deal with this situation? Well, you do a soil test. The soil test will give you an idea about what's in your soil. And then after that, you will establish the important things. Do I need to apply lime? That's one very, very important thing. And these, I'm going to reveal a little secret here for you. These figures have been taken from our property. Okay? And I look after our soil pH. If there's one thing that I do well here, because I've got limited energy and not enough time to do things as well as I should, I look after the pH. But even though I adjust the pH to be around the 6 mark, we still have aluminium in our crop. 22, 20, 12, 40. Now, if I leave the pH where it is, 5 and below, you can rest assured that those figures will be maybe 5 times higher, 10 times higher. So it is very important that you first of all adjust your pH. And then, if you want to do a leaf analysis, by all means. But if you're growing 10 different crops on a little piece of land, you realistically cannot do that. So you familiarize yourself with the deficiency symptoms that you are likely to get on each crop. And the soil analysis will give you an idea what these things are. And then you are watching these crops like a hawk, and the moment you see that there is a deficiency, you apply that mineral, or you can be proactive and say, look, my soil is low in manganese. I'm going to most probably end up with manganese deficiency. I'm not going to wait for this symptom to appear. I'm going to apply it now. Be proactive. We will be showing later on, weather permitting, the rain is going to stop eventually. Never complained about the rain, by the way. We will be looking at deficiency symptoms, and I will give you guidelines to help you establish what deficiency it is or what symptom it is. Most importantly, really, with that is to know, first of all, whether or not it is a nutrient deficiency, because not every symptom on the leaf is actually a deficiency symptom. I think I will stop here for today and be back with you in the next session. Thank you for listening.